Hello, hello, hello. Welcome to one more episode of Shikshak 101. It's about openCV today, which is actually an open source library called Computer Vision. It's a very powerful tool. It is open source and you can play around with it in a lot of ways. Come up with your own tools, implement existing tools. That's your decision to make. But it's a amazing library. So I'll just give you a 101 about it today. So the library is for computer vision and image processing tasks. The use cases that we will cover today is how do you process an image, how do you detect an object, and not really a facial recognition uh, topic today, but yeah, since you will get that openCV understanding, you can also leverage the facial recognition inbuilt features that openCV provides. So the requirements would be you need a desktop, a computer, a machine, a laptop, something which can process your commands and give you an output. You need the Python environment. You need an openCV library. You need IDE and you need a video or image to process. The steps that I'll cover in this video is how to set up the Python environment, how to install the OpenCV library using pip, uh, and so I would not really go into the Windows shell and show you, but more or less the commands are same. There's an additional overhead for the Mac users, wherein we will have to use the conda environment to actually run the or download the OpenCV libraries. And I'm using a Linux terminal, and mostly the commands are pretty much same for a Windows terminal. Like in this case, since you need a Python environment, only the path setting and all those things will change, but overall, the running of the code is pretty much same. Like I said before, I'm using a Mac to show this demo. So I'll give you that extra amount of commands or extra effort that is needed to run OpenCV on a Mac. So these are the commands. Like I said, uh, first we need the to get the Python. So I am using a reinstall because I already have. You can just do a brew install Python if you are using homebrew. And then you can go to this particular website to get all the conda related steps and stuff to get a Python environment. OpenCV libraries. I'm using a Python 3.12.8, I guess. So you need to give just the first half of the um Python version, not the exact one. So it basically utilizes that, and then you just activate the profile that you created, and then you install it, and yep, you will be ready to use OpenCV libraries. Let's go. Python, I'm doing reinstall, like I said, because I already have a Python in my local, and you can just do a brew install rather than reinstall in your case if you don't have it. And if you have it, you actually need not do this step at all. So if you see, it's trying to go and fetch, and it does a reinstall for the library that I asked for. The version that I asked for, and here we go. We are done with it. Okay, so if you see, we already ran this particular command to reinstall Python. This is the page where you can get the steps. As of I will not use it. The next command that I need to run is this one, which will actually create a profile called OpenCV using the Python that is there in my local. So now when we are done with this, you see it's suggesting the next set of commands, and that's exactly what we are going to do. The next command is conda activate the profile that we have set. Okay, so I'll say I'm going to activate this. Yeah, it was conda install openCV. My bad. So it is conda install openCV. Pip3 is a different thing. But since we are using conda, we need to use conda commands only. Okay, so let's go to IDE, code. There's a code. Okay, let me do one thing. Let me start with a very, let me start with a new file. Okay, and we'll use that. Give you a tutorial, demo, py, create a fresh one. I already created one, but then I'll just pick up the important things from it. First of all, first and foremost, we need the CV2 library. We get that. After that, if you see, I mean, ignore this method. Then we need to get the video. So this video is there in my local, right? And then once the video is there, we want to display the video. So we'll go one by one. We'll not go directly into, um, you know, the other command. We'll start with the basics, right? And so to show the video, we use an im show method that is the part of the library itself, and we'll write a while condition which will actually read the video. So if you see here, we have a capture or CAP method that is there, and there's a while loop that we say that, okay, if it is an open state, read the video and give us the frame and RET parameter from it. Uh, so and apart from that, since we are in this one, we are just showing you what's going on frame by frame. I'll just take this part of it and maybe this part also. Okay, so this is a very basic operation, like I said, which will capture the video. It's the video. Where are you? Yes, this is the video. So FYI, that's me bowling. So if you see, it's showing me the video replay. That's okay. And now, if I press Q, uh, it will. Now I pressed Q and it came out of that loop. So basically, it was in a while loop. It needed a break statement, which is the Q command in this. Okay, continuing that. That was me bowling, and I play for a club in Hyderabad. A fast bowler, come batsman. So what we'll do is we'll capture a gray. Uh, we'll convert the existing image that we got into a grayscale image, right? And um, we will print that grayed out image after that. So we have the frame. I'll put this part in there. So if you see, I just simply do a CVCVT color, give the frame, and then color to blue to gray. Basically, color to gray out. And I'll change the input to this particular. Here we go. Okay, so my bad. Gray over here. If you see, yeah, now all the colors has been converted to gray image. So basically, it's either white or black, right? Okay, so this was a little more advanced, I would say, little more advanced version of image processing. The second one is you can do actually a lot of things in this, and this area is so vast that I cannot just give you everything in a day. But in this example, I'll just give you a small example of how to isolate things and how this actually works, right? Okay. So yeah, we'll go and import the NumPy library as well to run this command. And here we go. Now you see it's only displaying you the colors, or maybe I would say the moving uh, objects. So how it does is it basically compares two images, consecutive images, and once you get the consecutive images, you will be able to actually get the moving object. So if the image is stable, basically nobody is moving. But if somebody is moving, then the consecutive frames will be different. So you get an understanding based on that, that yeah, somebody is moving. And actually that's what it's doing in the first part. Okay. And that's how cool I would say image processing is, right? Yeah. Let's go back. Uh, so this is the first part. Then what I'll do is once that is done, we'll apply thresholding. These are some standard techniques. You can read more about it in this before we show. Um, let's just go over it. So basically, what it's doing is, okay, let's go back and get this command as well. So first it finds all the contours, right, and puts it in a variable called contours, and then we'll loop through these variables, and then we'll find the area of these contours. So these are all inbuilt methods in CVT, that's what I said. And then we'll say if the area is greater than 100, just draw a bounding box around it. So these are the X, Y, W width and height coordinates of that contour uh, once the rectangle has been uh, once it gets the size of the contour, right? And then based on that, we'll create a rectangle on the image and we'll give it the XYZ, XY, similarly XY width and height coordinate uh, in that. Basically XYZ coordinate and then the size of the rectangle, right? To be very precise, this CV2. We'll see another example where it will only do isolation for the bigger ones. Let's go 2000. See what. No, my bad. It should be not less than, but wait. Right? Not the, we don't want the smaller ones. So you see, it's a good technique to isolate some people. Like you see, you can actually identify moving people using this, like the initial part, I would say. It's able to capture whoever is moving as a whole unit. And here we go. See, as this guy moves, he's also getting into the picture. Let's make it much more obvious and faster. So let's make it 5 and maybe let's make it 2000 and see what happens, right? Clearly, it's isolating it much better as a getting the moving person in the picture, right? See, it's kind of bounding me well and then it gets the whole thing. But yeah, you get the idea, right? How these things work. Um, yeah, that's pretty much what I had for today's demo, and that's all. I think we are done with the demo. What I would say is go around, play with it. There are a lot of interesting things that we have in it. For example, like I said, it also gives the facial recognition. Yeah. So do share your feedback and thanks for watching. That's for sure. A lot of gratitude to you guys that you are watching this, whoever is watching this. And do share your feedback to me. Please like this video and keep learning. Thank you. Bye.